CloudDB, shaping your new normal.
Our event will be the biggest one ever done with 144 sessions, including normal sessions, workshops, and hands-on labs from 100 different speakers over 18 days. Also, it will cover sessions in 4 different languages. Please remember to register to as many sessions as you can. This way you'll be able to access our replays until December 30. I would like to say thanks to our Oracle user groups and Java user groups that made this event possible, and also to our sponsors, Oracle Groundbreakers and Untitled sponsor CloudDB. Now for today's session, learn analytics and machine learning with Red Bull Racing. Predict the top 5 finishers in the next race with this hands-on workshop. It's now time to create your free Oracle Cloud Infrastructure account too. We will start very shortly, and this is with Olivier Perard. If you have any questions of issues, please feel free to use the chat window in the right lower corner. Oliver is just posting some information. He just posted the link to register to the free account of Oracle Cloud that have a trial that would not require you to enter a credit card either. And the lab instruction links too, and the lab instructions is step by step. Saying that, I will leave you now without any more delays with this amazing session by Olivier Perard. Oliver, the room is yours.
Okay. Hello, developers. Okay, today we have 2 hours, okay, to do some hands-on labs, okay, hands-on labs with machine learning using the Red Bull Racing dataset. And the objective today is to try to predict the top 5 finishers, okay, in the next race during this hands-on labs. Okay, you have the link on the chat to create your free trial account, okay, or you can use this QR code to access to your account, okay. And you need to provision your free trial if you want to test and to deploy the hands-on labs, okay. I will begin with a short video. Okay, my name is Olivier Perard. Okay, I'm working in the developer relation team. And today I will show you these hands-on labs, okay? If you have some questions, okay, you have some link at the end of this session, so you put your questions in the chat or in the Slack channel, okay? In the Slack channel, you can connect to the APAC GBT 2021, okay, slack.com, and you have a channel, APAC GBT 2021 to put your questions, okay? I have some help, okay, from Nacho Martinez, okay, to respond to these questions, okay. If you have some questions or some problem to provision your account or to create to deploy the hands-on labs, okay. It is a link, okay. You can create, okay. If you have not been, if you are not whitelisted, okay, don't worry. You need to put only, okay. You have with this link, you can create a free trial with $300 in your account, okay. And if you have not been whitelisted, you need only to put your credit card, but you don't have any cost. And if you don't activate your account, okay, they don't use your credit card, okay. And you have the link here, okay, and you have 30 days, okay, with $300 to test these hands-on labs, to develop more, to test more services, okay, and you can use some free, always free trial account, okay. You can create 2 virtual machines, and you can deploy an autonomous like always free, and you have this tenancy for the different use cases you want to implement, okay? Donc, it's really important to create your tenancy, your cloud infrastructure tenancy, And you should test this console lab. You should deploy these console labs on your account, and you can practice with me, okay, at the same time, okay. Now I will show you, okay, the video from Victor Martin, my colleague, okay, to explain how you can provision this free trial.
Hi, I'm Victor Martin from Oracle Cloud. I'm going to walk you through the steps to sign up for an Oracle Cloud free tier. Please follow along and pause the video when you need it. Oracle Cloud free tier gives you a set of always free cloud services. These services will be available forever. 2 autonomous databases, 2 virtual machines, up to 4 ARM processors virtual machines. You will also have a load balancer, block, object, and archive storage, monitoring, and much more. As part of your Oracle Cloud free tier, you will also have a 30-day trial with free credits to use in other services from analytics to Kubernetes. Sounds good, isn't it? Are you signing up for an upcoming workshop with us? Please make sure that you use the same email you use for the registration, as we have activated a special offer and you won't need your credit card to sign up. In any case, Oracle Cloud is not going to charge you for your trial. You actually have to explicitly tell us so when you are happy with all the Oracle Cloud services after your trial. Let's dive in. You need to add your country, then your first and last name. You also have to provide your email. Oracle Cloud has to check you are a human by asking you to resolve an easy challenge. Finally, click Verify my email to move to the next step. If your email has been activated for the offer, you will see the special Oracle offer pop-up window with the type of offer already selected. Then click Select Offer. All the initial information is already in. Now you have to provide a strong password. I use a generated one, but you can select any you like. Just make sure you are in compliance with the strong password pattern. Confirm the password by typing it again. Fill the company name if applied. The cloud account name is essential as it is a unique identifier for your account. Select a name you like that is not taken. The home region is the region where you are more likely to deploy resources. You can deploy to other regions by subscribing to them. However, your free trial only supports one region. Select a region geographically close to you if you are not sure. I'm selecting Frankfurt region. At the bottom, click Continue. Fill the address information with city, postcode, county, and your phone number. Click Continue. The final step is to accept the agreement and click Start my free trial. Oracle Cloud starts provisioning your account. This takes on average 1 minute or 2. Then you are going to be redirected to the Oracle Cloud web console. Can you see the message, your account is currently being set up? It means that some services will still be unavailable for a few more minutes. Just keep it in mind. After a while, the message saying that your account is being set up will disappear. After a few minutes, you will also receive a Getting Started email and another one when your trial account is fully provisioned. Use the button in the email to sign in whenever you want in the future. You are all set up to enjoy your new Oracle Cloud account. Happy hacking! Hi.
Okay. It is a presentation from Victor Martin. I hope you have provisioned your account. Okay. In the last window, okay, if you have not been listed, okay, you need to put some credit card, but you are using the free trial. Okay. And if you don't change your free trial to a paid account, okay, we don't charge on your credit card. I put on the chat the 2 links, okay, on this the official website, okay, in the GitHub for this Hanson Labs, okay, with Oracle DevRel team, okay. It's a Red Bull Analytics Hanson Labs, okay. And I put another link, okay. You can use this link, okay, to execute the Hanson Labs, okay, and to follow the execution with me, okay. You have these 2 links, okay. You can you need to open these 2 links, okay. And you have all the information to deploy the Hanson Labs. Now I will show you a video from Red Bull, okay, to understand why we are using the dataset from Red Bull and the dataset from Formula One, and what is the objective to deploy some machine learning algorithm for Red Bull. Sorry.
We compete in one of the biggest sports in the world. There's always adversity. You're going to lose more races than you're going to win. But it's those days that you learn the most. Data is our lifeblood in Formula One. Everything we do is driven by the data that these cars create. We're not allowed to practice like in other sports. So we have a virtual world, which we rely very heavily on, but also on the data that these cars generate and how we use that data. And we need to be more personalized. And look, we want to be able to give the fans an insight that they can't get anywhere else. We're in a fortunate position where we can afford to be quite choosy of the partners that we want to work with. It's not just about having a sticker on the car. It's about the technology that it puts into the car as well. And so therefore, a partnership like the one we have with Oracle, the technology that opens up to us is so exciting. At the end of the day, it's about working with your team to try and take on some of the best teams, some of the biggest brands in the world. And when you achieve that, that's the biggest sense of satisfaction.
Okay. After this presentation, to understand why we are using the data from Red Bull, okay, I will explain the journey for this Sensor Labs, okay. It's Sensor Labs for beginners, okay, because we will deploy some very simple machine learning algorithm on the cloud platform from Oracle. And the journey for this Sensor Labs is the data collection of the data set, okay. I will explain how you can use this data set. And the second step on this Sensor Labs is we will prepare the data. Okay, we will merge some data set to create a big data set to apply the different features in the machine learning model. We will execute some exploratory data analysis, okay, on this lab, okay, to understand what we can do, okay, on Jupyter Labs on this platform. We will deploy some machine learning models, okay, around six models, six machine learning model, okay, to compare the different accuracy and to search the best model, okay, and to tune this model. After that, we could publish this model like a model serving, okay, with the best training model like a REST API, okay, we will publish like a REST API. And at the end, we will deploy a very quick web user interface to access to this REST API and to search, okay, the best drivers for the next race, okay. Okay, you have all this information here, okay. It is a step, okay. Here in detail, okay. The first step, we need to deploy the Jupyter Lab, okay. Okay, I will explain now how you can do it, okay. We will collect, okay, it is the name of the different Sensor Labs, the different notebooks we will use, okay, on this session. Okay, we have, for example, the 010, the data collections, okay. We will search some information for the weather on the website because when you download this information from Formula One, we don't have the weather information that we can connect to another website to download the weather information from Formula One. We can use some qualifying data. Okay, we can collect this information. Okay, on the qualifying to deploy my model or to develop my model. The second step is to prepare the data. Okay, we merge this information. Okay, because we extract this information from different websites, and we need to merge this information. We can develop some exploratory data analysis notebook, okay, to analyze more information on this notebooks, this data, and to discover some patterns, okay, directly on this information. After that, we can implement some machine learning model, okay, on the Jupyter Lab. Okay, we will use very simple for beginners, very simple machine learning model. The next notebook is to publish the model serving, okay, directly to use on the to deploy a predictor, okay, on a web in a Flask application, okay, and we can use these applications directly from Flask technology to publish a REST API, and we can use this REST API directly from one web interface. Okay, it is the Console Labs. Okay, now I will stop sharing my presentation, and we can do in live. Okay, I will share my screen. Share my screen now. Okay, share my screen. Okay. So the first step, okay, you have this link and this link, okay. In the GitHub, okay, you have all the information. Okay, we download this information in the Jupyter Lab. Okay, you have some explanation here. Okay, to execute this Console Labs directly from this link. Okay, on the GitHub Oracle DevRel, and you have the beginner tutorial here. Okay, if you click on the beginner tutorial, okay, we have here, okay, the Console Labs to deploy this Console Labs, the different steps. Okay, the first step is you have created here, okay, I will disconnect and reconnect to my, okay, I have created a tenancy, okay. I can use my connection with Oracle Identity Cloud Service. I can connect to my cloud, okay. You have this window with your email account, okay, and your password. You can connect to your tenancy here, okay, and here, okay, you have some information. Okay, you have your information of your user connected here, okay, on the top right. You have this icon, and you can check your profile. By default, okay, you can connect with your login password, okay, your email, or you can connect to Oracle Identity Cloud Service. Okay, the Oracle Identity Cloud Service is a service to connect to Active Directory, to an external authorization mechanism. Okay, you can connect directly. Or you have here your agent. Okay, you have chosen on the registration process. Okay, using a free trial account, you cannot connect to other region. Okay, only if you have a paid account. Okay, you can do it. Or you have all your information at your account here. Okay, you should have $300, or it depends. I have my in euro. Okay, 250 euros here. Okay, and you have the number of days for your trial. Okay, you have 30 days. Okay, when you provision your account. Okay, and now you can use this button here, okay, or we can use this information here. Okay, the first step is you need to generate the SSH key, okay, from your Cloud Shell, for example. Okay, now you can come here. You have an icon Cloud Shell, okay, on the top right. Okay, you have this information, okay, on the top bottom bar. Okay, and you can click on the Cloud Shell. When you create this information, okay, when you click here, okay, we attach a virtual machine, okay, with 5 gigabyte for storage, okay, to your tenancy, okay. So you have this information, and here you can see, for example, okay, you have your account and you have a federated user, okay. It is the same user I'm using in the connection here, okay. And here you can create, for example, okay, you can create a directory .ssh, okay. I have creating this directory, but you need to create this directory and you can go to this directory, okay. For example, here, okay. And I will delete this, okay. And if you want to create an SSH key, okay, because to provision the console labs, okay, we need to add an SSH key, and you can connect from some tools like PuTTY or other tools directly, okay. You can use this command, okay, sh. You put here this command on your tenancy, okay. You put SSH keygen, okay, -b 2048, okay, the format RSA, and you put the name of the files, okay. You can generate this key directly, okay. You don't put passphrase, okay, no passphrase, and you have generated a public key and a private key here, okay. You have the private key, Cloud Shell key, and your public key, okay. You can show your key, Cloud Shell key, okay. You can cut, and you need to copy, okay, directly this line, okay. Right button, copy, and you can store this information, okay, because you need this information to provision, okay, later the console labs, okay. Any problem? I will check on the sessions. Okay. Sorry, here. Okay, donc we are generating this key, okay? Donc in the Cloud Shell, okay? We can use this Cloud Shell, or you can generate on your PC, okay? For example, you can generate using the tool in Windows, or you can generate the same key using your Mac, okay? Or your Linux, if you have a Linux, okay? Using the same command, okay? SSH keygen, okay, to generate this key. When you have this key, now, okay, we are executing the first step, generate the SSH key, okay, you have this information here, you have this information here, okay. We can execute, we can provision the console labs, okay. To provision the console labs, okay, here, okay, we have created a Terraform script, okay. In the cloud of Oracle, okay, here, okay, if you put, for example, the stack here, okay, we have a service, okay, here. This service is a resource manager, okay, where you can deploy the Terraform, okay. If you don't know what does it mean Terraform, it's a tool to create scripting and to deploy automatically lots of platform, lots of architecture with one click, okay. Donc in this case, okay, here in the console lab, okay, you have this button deploy to Oracle Cloud, okay. When you click on this button, okay, we execute directly the script, okay. I will click, for example, okay. You execute this script, okay, directly to my account, okay. You can see on the top, okay, you have your credit, $300 or 250 euros, okay, and you have this information. Okay, I will refresh my browser. Okay, if you don't upgrade, okay, you are using, okay, directly the always free resources. here you have this stack, okay? We open directly the stack module, okay, in the Oracle Cloud, okay? The stack module is in the top, okay, in the hamburger button here. And you can see here we are executing from Oracle DevRel, okay? This information, this zip file, okay, with the Terraform script. You need to click on I'm okay to execute this information, and you in the zip, okay, we have the information Red Bull, Honda Racing Analytics, Console Lab environment. Okay, we will provision directly the platform, okay, to execute this Console Labs. Donc you have this information here, okay, and you have a compartment, okay. You can, if you are connected to a free trial, you can choose the root compartment. Okay, the compartment is an organization in the cloud to organize all your resources and to assign the rights and the different rules for the different users, okay, to access to different resources, okay. Donc, using the compartment, you have the root compartment. We have the version of the Terraform script, okay, using for this. And you click on the next. And here you need to configure the compartment name where you want to deploy this platform. Okay, by default, okay, we have configured Red Bull Hanson Labs. Okay, this compartment, okay, will be a child of the root compartment. Okay, we will create this name. Okay, and here, okay, you can upload an SSH key or you can paste here, okay, your SSH key you have generating from the Cloud Shell. You put here your key, okay, and you have this key here. Okay, you choose Oracle Linux 7.9, okay. It is the last version of the compute image, okay, we have prepared for this Console Labs, okay. And the next step, we put 2. Okay, you have the stack information, okay, where you want to deploy your compartment, okay, put Red Bull on Sun Labs, okay, put 2 because I have deployed it before, okay. You have your SSH key information, okay, and you need to select Run Apply because you want to apply, okay, you don't want only to check this Terraform script, you want to apply this Terraform script directly, this configuration on your tenancy. And you put, okay, you can click on the create, okay. When you click on the create, okay, you should have here, okay, you click on the create and you have a job, okay, we execute a job information, okay, and this job, okay, we need to wait around 5 minutes to deploy the Console Lab, and you should have this information succeeded, okay, when this Console Lab has been deployed, okay. Okay, I will show you the result, the final result here, okay. I don't apply this, I have deployed before. I will show you my executions, okay. Here I am executing, okay, I have creating the Red Bull Console Lab, okay, and I have in my stack, okay, deploy yesterday, okay, I have this stack, okay, my plan has been executing, okay, and now here you can check, okay, your job, okay, you have a job at the end, you have a job information, okay, and you have the log of your job, and you have the output information, okay. I will show you the log, okay. Look, when you are executing at this moment, okay, you are executing the Console Lab, you are deploying the different platform, okay. We are executing with Terraform, okay, with HashiCorp. It is a company that is developing this Terraform stack. Okay, this stack is using by the different cloud provider, okay, in the world. And we apply this script, we deploy the platform, okay, we create directly virtual machines, we deploy a networking, okay, and this script is deploying instance, okay, for the Red Bull Hanson Labs, okay, and you have here some information, you can follow all the executions, okay, and we are executing remote executions, okay, on this virtual machine to execute some script. At the end of this script, okay, we are creating and we are configuring the Jupyter Labs, okay, for this console labs. Sorry. Okay, we are deploying here. You can check it. Okay, we are writing the Jupyter Labs. Okay, we are configuring the Jupyter service, and we execute the Jupyter service. And you have some information at the end, the output. Okay, we need. Okay, you need to store this information. Okay, you have the output here. Okay, your get Jupyter token. Okay, and you can show. Okay. You have your IP, okay, and we are executing the Jupyter with SSH, okay, with your key, and with and the port 8888, okay, 8888, okay. We are using this port. In the documentations, okay, here we have some error here, okay. It was a previous installation. Okay, we are changing the script to deploy quickly on the different virtual machine. You can test with different virtual machine. Okay, in this documentation, okay, we put 8001. Okay, but we are changing this port. Okay, because now we are creating a new secure list. Okay, to open on the 8888. Okay. Donc, and now in this photo, it's a Jupyter notebook, and now we are changing with the Jupyter Lab. Okay, and we don't create a password by default. Okay, in the previous version, we have this password Red Bull 1, and now we don't have this information. Okay, donc you need to use this command. Okay, with your private key. Okay. To connect to your IP with OPC. OPC is a user by default creating, okay, and you can connect directly to your Jupyter. Okay, you can check what is the token. Okay, we have deployed the Jupyter Lab, and we are creating a specific token per virtual machine. Okay, okay, if you want to check this, okay, you need, for example, I have creating here. Okay, I have creating, you can use PuTTY, okay, for example, I'm using PuTTY. You can use PuTTY, and you can create a configuration here. Red Bull, okay, you can, with my IP, okay, look, you need to put your IP, and you put here in the connections, authorization, okay, you put your PPK, okay, your private key here, okay, to connect. Okay, you have your information here, okay, and if you execute source Red Bull Hanson Labs, okay, you can check your Jupyter, okay, your Jupyter Lab and your token. When you connect with your token, okay, you need this information, okay. I will wait, okay, for your provisioning and your executions, okay. Or you can execute from your PowerShell, for example, in Windows. Okay, you can execute your PowerShell, and the SSH is available, okay. All the commands from SSH are available on this platform, okay. SSH, you have this information, okay. Or you can use your command line, okay, directly here. Use SSH. In Windows 10 or Windows 11 is available. In Mac is available, okay. You can use SSH. Okay, you need to put, okay, if you want to check directly this information, you need to copy this. Okay, you need to copy, and you need to go to your platform here, for example, command line. I will use my command line. Okay, and you need to use your private key, okay, here, the path, okay, your SSH private key, okay. Look, my private key, if you check on your here, okay, you have the public key and you have the private key here. This is a Cloud Shell key. Copy, paste. Okay. But you need to copy these informations, okay, to your private key. Okay, for PuTTY on Windows, okay, you need to use the PuTTygen. Okay, the PuTTygen. Okay, and in the PuTTygen you can load, okay, this private key, and you can generate the PPK. Okay, it is a RSA. Okay, you can use this information to create your private key. Okay, look, I will wait. Okay, put on the Slack or on the chat if you have some problems. Okay, and if you are ready or not. Okay, I will wait 5 minutes to be sure that you can execute this information. I will check it. Okay. Okay. Okay, it is a provisioning. Okay, when you have the green color here, okay, you are ready to connect to your PuTTY sessions. Okay. Now, when you provision your information, okay, after that you can connect to your HTTPS, your IP, and this port. Okay, I will show you now. Okay, well, it is a provisioning. Okay, in your environment, in the compute. Okay, we have deployed here an instance for this information. Okay, here, for example, I am with my compartment root. Okay, you need to choose the Red Bull Hands-on Labs. And here you have this machine, Red Bull Lab 1. Okay, we have deployed this, and you have the IP here. Okay, the same IP you can see on the stack. Okay, you have a public IP and a private IP. Okay, we have deployed a virtual machine. Okay, with two CPU. Okay, 30 gigabyte. Okay, if you check here, if you click on the Red Bull Lab 1, you can see the username by default is OPC. Okay, it is my IP, my public IP address. Okay, it is the image we have used. Okay, Oracle Linux 7.9, and we have creating a virtual cloud networking. Okay, a VCN. Okay, we are creating a VCN. If you want to add more machine on the same network, okay, you can use this VCN for other to deploy other machine. And here you have your subnet. Okay, if you click on the subnet, here you have a security list. Okay, and if we check the security list we have created with the stack, the Terraform script, okay, you can see here. Okay, you can connect to the 22. Okay, using SSH. Okay, using your private key. You can connect directly here. Okay, we have opened the 888. Okay, on the public IP here. Okay, for the Jupyter Lab, and we are creating. Okay, we are creating another security list here. Okay, for the other port 8443 for the predictor web service. Okay, and we can test. Okay, from my PC or your PC, you can test directly to connect to this information. Okay, donc we are creating all these informations. Okay, on the security list. Okay, on the ingress rule. Okay, donc you have your virtual network creating Red Bull VCN. Okay, you have different route table creating, and we have deployed this Red Bull VCN. Okay, directly for your environment. Okay, we are creating this VCN. Donc now you have all these informations, and here, okay, on my compute, okay, in this information here, okay, you can see on the compartment organizations, okay, I have my root compartment, okay, a specific compartment for specific services from Oracle, managed compartment, okay, for past service. And we have the Red Bull Console Labs compartment, okay. In this compartment, we have your instance, and you can connect now using this URL, okay. You can connect. You need the token, okay. At the first connections, you need the token, okay. You need to put your token. You have a specific window, okay. You put your token and you can assign a password, okay. In my case here, okay, I have assigned this password, Red Bull 1, okay. You can put the password that, okay, you want to put for your Jupyter Lab environment, okay. You choose the password. You need only the token, okay. You need only to take this information here, okay. You need the token. You need to take this information, okay. With this token, you can assign a specific password for your Jupyter Lab environment. And when you are on your environment, okay, we have downloaded, okay, all the information, all the different scripts, all the resources for this console labs, okay. And this information is in this repository, okay, the Red Bull Analytics Console Labs beginners, okay. So now we are ready for the next step. Okay, we have creating the environment, we have assigned a password. Okay, we can access now to the data collections. Okay, so the data collections here. Okay, we have this information on my hands-on lab. Okay. We don't execute, but you have the original, okay, because we don't have time. Okay, you need 40 minutes, okay, to download all this data set, okay. We have downloaded this information that you have all the data set, okay, directly on the data directory, okay. You have this information, this different CSV here, okay. And you have in the Formula One another data set, okay, coming from the different website, okay. So we have two directories with the different informations, okay. And the original script from scratch, okay, it is this notebooks, okay, the 1, the 0, the 1, and the 2, okay. This information, okay, is using, if you can check it, okay, we are using the Airgast web interface, okay. If you check, okay, the Airgast, it's an API, okay, for Formula One, okay. You have this information here, okay. It is for developers, okay. You can connect, okay. Well, you have some specific license, okay, to use this information, okay. You have some control on the data flow, okay, to extract this information, but you have all the information from the Formula One. And after each race, okay, you can access to the updated information, okay. Donc, they store all this information. You have this information, season list, qualifying result, constructor information, lab tab, okay. You have all this data set, okay, the pit stop, and all this information, okay, you can access, okay, using the API to download this information, okay. So we are using this API to download, okay, here from the Airgast web interface, okay, and on the 01.0, okay, /0. We are using this information, okay. For example, we are downloading the information until this year, okay, and you are using this information, the API, okay, Formula One, okay, and we can put the range here, okay, from 1950. We have this information in the Airgast web API, and we can access it. We can store this information directly in the CSV, okay. We download this information here, okay. We execute and we store this information in the race CSV, okay, on the data directory, okay. Okay, it is the original script, okay. This script, this free script, okay. You need 40 minutes to execute, okay, to execute of this script, okay. It is a result, okay. We have simplified for this console labs, okay. We have prepared the data set, okay, but you have the original code to execute this code, okay, if you want later, okay, when you have time, okay, after this console labs, okay. But you have all this information. We store this information, okay. We can look up by the constructor. We have this information with constructor point, okay, the number of wins. Well, we have lots of KPIs, okay, on this information. Okay, you can see the time, okay, for the execution. But it's depending on the flow, okay, and depending on the number of users connected to this website, okay, to download this information. For the wizard data, we are using, okay, we are using the race dataset here, and we check this information, the wizard, okay, the information with the wizard on this dataset, okay, and we access on different websites to check this information. Okay, here, for example, we convert this wizard. Okay, you have sunny. Okay, you have different warm, dry, and sunny. Okay, you have different information. Okay, and we create another KPI. Okay, with this information here, we create a dictionary, the wizard dictionary. Okay, to create some category directly on this information. Okay, wizard dry, wizard cold, wizard warm. Okay, wizard wet, and wizard cloudy. Okay, because probably in my machine learning model, okay, the wizard is a very important feature to predict the model. Okay, it is the initial ID. Okay, no, we store this information, we convert this information, okay, on these different column here. Okay, and we create this data set. Okay, it is some derived features. Okay, creating from this column. Okay, directly. Look, we store this information on the wizard CSV. The other notebook, okay, qualifying data collections here, okay, we are extracting the information from the website Formula One here, okay. This website, if you take here, okay, you can execute some web scraping, okay, directly on this information, okay, because accept, okay, you have information on the different drivers, okay, you have information on the different standing, okay, the different team, okay, and you can access, okay, if you pay, you can access to the live timing, and you can extract this information directly from the different Formula One races, okay. We can create a streamer directly on this information. Okay, here we are using, for example, this result, okay, this in English, this result.html, okay, and we are checking the races HTML, okay. Like we are using the beautiful soup to execute the web scraping, and you can filter the information, okay, on this website, okay. And for example, we can extract more information. It's an extended information. It's an information we don't have in the Airgast API, okay. Donc we can extract this information, okay. We have the different best time, okay, on the qualifying sessions, okay, depending on the session, or you have all this information, okay. We can store, okay, qualifying results directly on this data set, okay, qualifying CSV, okay, and it is the time, okay, for these executions. Yes, is it clear? Any questions on this part? It is the original notebook. You can execute this notebook, okay. And now for this console labs, okay, you can execute this information, okay. 0.1.0, okay, on the main directory, okay. Okay, here in the data collections, okay, the first step here is to execute, okay, the same console lab, but we are reading directly this information from the data directory, okay. Okay, you can see this information. Okay, we are executing for the different, okay, we have the different season here, okay. Now you can execute this notebook. The race, okay, you have the race's tail, okay, here, okay, you have some information on the Wikipedia, okay, you have a link in URL on this data set, and you can access to some information here, okay, on this data set. And you have the Formula One rounds, okay, information. Sorry. Okay. And the race result, okay, we can use the race result. Okay, you have this information here. Okay, I can click. So race results. Race. Here, okay, you have this information. Okay, the data set, you have the season. Okay, you have all the information from 1950. Okay, you have the different circuits, the different driver. Okay, information on the nationality. You have information on the podium and the number of points. Okay, you have different information here, and you have the URL. Okay, here where you can check some information on the different pilot. Okay, and more information. Okay, now here we are using the result. Okay, you have this information. Okay, the different driver, the nationality of this the different driver. You have the constructor. Okay, on this period, and the different circuit. Okay, for example, for 2020. Okay, yes, Marina. Okay, it's a new circuit. Okay, from the last 5 years or 4 years. You have the driver standings here. Okay, and you have some information on the driver standing. The driver standing here. If we check this information, okay, you have the driver name. You have the driver point after race. Okay, the driver wins after race. The standing positions. Okay, the driver points. The driver wins. Standing positions. Well, yeah, all this column on this information. Okay. And you have the constructor standing. Okay, we have these informations. Okay, and if you check the feature distributions, okay, we can plot. Okay, we can use some plotter. Okay, with matplotlib. Okay, we can plot the informations. Okay, we can check the distribution on the different feature. For example, here. Okay. We are checking the feature distributions, okay, and the different information. We can check the relationship between comparing feature to feature, okay. Donc we are using a scatter matrix, okay. We are creating a correlation matrix to understand which feature is really important in my model, okay. Donc we can use this information. We can understand here, okay, with this plotter. We can understand the distributions, and we can check the correlations between the different features. For example, okay, donc, you have some, okay, you can see here, it's a line, okay, it's directly a line. Okay, donc you can understand your data, you can understand your correlations, okay, to be sure or to discover already which feature could be important for my machine learning model, okay. But you have this notebook, you can execute 28 seconds, okay. You can execute this notebook. Here you have a button to execute all paragraph run. Okay, you can execute all cells. Okay, directly here if you want. Okay, okay, it is the first notebook. Okay, we are using the CSV. Okay, the CSV you have in this directory. Okay, in the 01. Okay, we are using the wizard. Okay, using this information, okay, donc we have seen, okay, we have some feature distribution here, okay, in the plotter, okay, for example here, okay, the wizard worm, okay, the number of race, okay, with worm status, okay, wizard cold, dry, wet, okay, and cloudy, okay. The most of time, okay, for the different race coming from 1950 to 2020, okay, 21, we have this information, okay. Donc we have, for example, here, okay, more races with warm status, okay, or not lots of race in weight, okay. Here you can see this information. On the data preparation, okay, on the next, okay, 01, 02, the data preparation building, 01, 02, qualifying. Okay, we are using this qualifying CSV we have downloaded from Airgast, okay. from Formula One website with web scraping. Okay, it is a feature distribution here. Okay, we have the grid positions, the season, okay, and the round, okay, information here. Okay, and you can check the relationship between the different features. Okay, here, okay, you can check the distributions. Okay, the relation between the different features on my dataset. Okay, 12 seconds to execute this console labs. Okay, these notebooks. Okay. Okay. Now we have different data set. Okay, we have downloaded from Airgas. We have downloaded the data from Formula One website. Okay. Now I can try to merge. Okay, after discovering the different features. Okay, I can try to merge my data set. Okay, using here. Okay. We have races, we have weather, we have qualifying data. Okay, my objective is for my machine learning model is to create a data set. Okay, a data set joining or merging this information coming from races, results, qualifying, driver standing, constructor standing, and weather data set. Okay, so you can build here. Okay. The different we can drop some column. Okay, if it is not important for my model, here it's the same. Okay, and we can merge, for example, this information. Okay, and we build a data set here with the weather. Okay, with a circuit, with a driver, the constructor, the grid positions. Okay. The podium, the driver point, the driver win, okay, the constructor point, okay, all these parameters, okay, we have discovering, okay, in the different features. We think this different feature should be really important for my data model, okay, for my machine learning model. Well, you can convert different informations, okay, the birth of the driver or the age of the driver. Okay, well, we have some here some conversions. Okay, we can drop null. Okay, we convert. Okay, we are cleaning the data. Okay, on these different functions. Okay, we can calculate the difference in the qualifying time. Okay, for example, we have the qualifying time and we need to calculate, okay, the difference in seconds or in minutes, in seconds normally, okay, between the different pilots. Okay, so we create, for example, here the qualifying time diff, the qualifying time on this data set. Okay, and at the end we generate this data set, Formula One DF final CSV. Okay, here with this information, and we could use this information, okay, in the next step. Okay, now I will use the data F1 dataset. Okay, this information, okay, you can download directly from Airgas. Okay, for example, here I will from the Airgas website. Okay, if you put Airgas CSV download. Okay. I think I'm not sure. Yes. Okay. You can download directly also CSV. Okay, from this website. Okay, they create a MySQL data image. You can import in MySQL, or you can download this information directly. The F1 DB CSV. Okay, .zip. Okay, you can download this information. Okay, after I think on the Tuesday after the final race. Okay, when the race is finished. Okay, 2 days later. Okay, we have this information updated on this website. Okay, donc you can download this information. Okay, and you can unzip this information on this data F1. Okay, you have all this information here. Okay, all the data set, not only few data set. Okay, in the first notebook here, we are downloaded, okay, we are in my from scratch. In this first notebook, we are downloading few part of this information. Now, using this CSV, okay, I can download all this data set, okay. The status, the season, the result, okay. The data model, I can show you the data model from Airgas, okay. I have this information here, okay. It is a Airgas data model, okay. You have all this information in the Airgas database, okay. The circuit, the driver, the constructor, the season, the races, okay, the pit stop, the lap time, the results, the qualifying, the driver standing, constructor standing, constructor result, and the status. Okay, it is a data model from Airgas. Okay, using this these web pages, okay, you can download directly this information. Okay, directly an image from to import in MySQL, or you can download the CSV. Okay, in this case, we have downloaded only the CSV. Okay, you have all this information here. And I will use all this information, okay, to execute some exploratory information, okay, some EDA information, okay. Okay, it's really important. The Formula One, okay, is changing the rules, okay, yearly, okay, and now, okay, if you compare 9050, okay, to 2020. Well, we have other pilot, we have other company, we have other informations, okay, and we have other constructors, and we have changing the rules in the last 10 years, okay. In the last 10 years, we have changing the rules, okay. We have changing the engine, we have changing the tires, okay. Now we are using Pirelli like tires. We are using engine, very complex engine, okay. We will, okay, we think, okay, to discover the machine learning model, it's not usable to use the data set from an IT50, okay. We can use for other use cases, but not for this use case. My use case is I would like to predict the next winners, okay, for the next race, or for the next top 3, top 5 for the next race, okay. Okay, it is my objective. Okay, we will use the last 10 years, okay, already on this data set. And here, okay, you have some machine learning model. Okay, we will use a scikit-learn. Okay, the very beginner library. Okay, when you use in Python machine learning model. Okay, we are using scikit-learn. Okay, well, you have different library here. Okay, we will use a specific library, super vector machine. Okay, linear models. Okay, we will use naive-based different methods. Okay, random forest. We will apply all these informations. Okay, we can use from the data underscore F1 directory. Okay, this data set. We will use this information, and we can dive on this data. Okay, for example, we can merge the data here. Okay, we create this information. Okay, with a different column here. Okay, we have all this information, race ID. Okay, we have the time, we have the result, the circuit ID, the positions. Okay, the millisecond. Okay, the fastest lap for this pilot. Okay, the fastest flight time, lap speed. Well, we have lots of features in this data set. Okay, we are creating this data set with all these features. And we can drop some column. Okay, not useful for my model. And we can use the year, date, okay, the grid, the pilot name, okay, the nationality, all this information, the country, okay, on this data set. And we can filter here, okay, with all the data from 2010, okay, the last 10 years, okay, we will use the last 10 years. Well, we can rename the column here, okay. And well, we can apply some specific method, okay, for the driver age, okay, in days. Or we can convert the the age in days, okay. We can clean the data, okay. For example, Alpine is a new name, okay, and we have lots of information from Renault, okay. Donc we need to normalize the data, okay. We need to clean the data, and to normalize the data, we need to put, if we want to use the information from Alpine, we need to use the information from Lotus, from Renault, okay. We have information in the last 10 years from Renault, from Lotus, because they changed 2 times, okay, the name, and now it's Alpine. Aston Martin, okay, the name was Force India, Racing Point, okay, and we need to normalize to Aston Martin, okay, because it is the same constructor, okay, in the last 10 years. Alfa Romeo, okay, it is a new name, and the whole name was Sauber. We need to normalize, okay, these informations, okay, and okay, we have some information from Alpine F1 team, okay, donc we normalize with Alpine F1, okay, and Alfa Tauri is a new name for Toro Rosso. Donc we are cleaning the data, normalize the data, okay, directly with these functions, okay, and here, for example, okay, we are changing some country, okay, on the data set, okay, the driver nationality, the constructor nationality, and here we normalize, okay, some rules, okay, to change, okay, some error on the data set, okay. Donc, it was free for French, okay, and it's okay, donc for France, okay. Bon. We have some error on the data set. We need to clean the data set, okay. Donc we have some functions to clean this information, okay. Donc we are applying all the data set. We are probably, in my model, it's really important to use a specific parameter, did not finished. What does it mean, did not finished? Okay, it means in lots of race, okay, some drivers does not finish the race, okay, and probably this parameter should be really interesting for my predictive model, okay. Okay, I need to store this information in driver does not finish, okay, and here is the same, okay, constructor does not finish, okay, because each constructor has two drivers, okay, and it's really important for my predictive model to be sure that I have these informations, and I can check if these parameters are really important or not in my predictive model. And here we have some exploratory data analysis, okay, for example, on the information on your driver. I will try to put, okay, here I will try to extend this information. Okay, you have the different, okay, information on the last 10 years. Here, okay, the different pilot, okay, with a number of points. The DNF ratio, okay, it is probably it's really important to calculate if this driver does not finish lots of races, okay. Donc we have a ratio here, okay, in this representation, okay. The same for the constructor, okay, to understand which constructor is really good to finish a race, okay. Donc we have this information here, okay. We are calculating the DNF does not finish ratio, okay, depending on the Formula One team, okay. Donc you can calculate here, okay. You can see Mercedes, okay, or Ferrari, or Red Bull, okay, are really important constructor, okay. They have a very low ratio of they finish lots of races, okay, here, and you have other constructor in this case, okay. Here we are comparing the driver points, okay, the percentage of driver points, okay, depending on the drivers, okay, and we have the same with the constructor. The driver's podium, okay, finish the percentage here, okay, and the driver, the constructor, the F1 team points, okay, here, okay. Donc you can understand which constructor has lots of points, okay, in the last 10 years, okay, because we are executing some aggregations in the last 10 years. Here we are executing the percentage, okay, for the F1 team. Okay, if you can see here, Mercedes. Okay, it's the good constructor in the last 10 years. Red Bull, it's a good position. Ferrari in third. Okay, for this information. Okay, now we have this information. We are calculating new KPIs. Okay, derived features. Okay, we are generating derived features using the number of points, the number of podium. Okay, all this information. And we can generate a data set for 2021, okay, because I want to predict for this year, okay. We train the model until 2020, and we can test with the 2021. Okay, we can try to predict the same machine learning model with the 2021. We have this information here, and we can calculate the did not finish, okay, the same method, we apply the same method for the last, only for the dataset for the last year, and you can generate a data filter in 2021. Okay, and you have these informations. Well, you can compare some exploratory. You can check the points. Okay, and on the last year, okay, well, it's not the same representation because we are only testing the information for the last year. Okay. And you can execute these notebooks in 26 seconds, okay? You can execute all this notebook, okay? It is an exploratory data analysis, okay? With this step on the process for machine learning, okay? It's a really important step to understand really which data we have. We can discover some pattern, we can discover some feature, or we can discover some derived features, okay, on this step. And we can apply, okay, for example, in my predictive model, only using some derived feature, okay. It's really an important step for data scientists, okay. Okay, it is the EDA notebook. Now, I will jump to the machine learning model. We want to predict, okay, the result of the different race. Okay, I will come back. Okay, and the objective is to apply 6 algorithms. Okay, 6 simple algorithms. Okay, this notebook. Okay, when you execute this notebook, it's 40 minutes. Okay, to execute this notebook. Okay, donc you can run this notebook, run all the cells on this notebook. We will apply logistic regressions. Sorry. Decision tree, random forest, super vector machines, okay, Gaussian naive Bayes, and nearest KNN, okay, nearest neighbor algorithm, okay, KNN. All these 6 algorithms, okay, we will apply all these 6 algorithms, okay, and well, we are splitting the data set, okay, previously, okay, and on the previous notebook, okay, and I will train my predictive model using the data set from the last 10 years, okay, from 2010 until 2020, and I can try to apply my predictive model to 2021, okay. And here, okay, we are using all this method, okay, the confusion matrix, accuracy score, okay, we have some important Python methods, okay, to apply directly and to calculate some really important parameter, okay, for my machine learning analysis, okay. And we are using this information here, okay, neural network, okay. Well, we are using my data set, okay, you can see here, this data set, the data filtering, okay, created in the previous notebook, in the EDA, okay. It is my data set, okay, from 2010 until 2020, okay. So you have all these informations here. Okay, we create a driver confidence dictionary, okay. It is the parameter using the does not finished, okay, the does not finished ratio, okay, and the confidence, okay. We are using the ratio and the confidence to finish, okay, the race, okay. It is a driver confidence dictionary. All the pilot has a specific coefficient, okay, depending on the number of races, okay. We are doing the same process to calculate the reliability, okay, for the constructor, okay. So we are using the DNF ratio, okay, here, okay, to calculate the reliability for a constructor, okay. It's really important. We create a dictionary for this constructor. Donc here, okay, we will filter the active constructor, okay. We will remove the retired drivers and constructor, okay. We will apply this because if you want to predict for the driver for 2021, okay, you need to select, okay, you need to use this predictive model only for the active constructor and active driver, okay. Donc, we filter all this data on the last 10 years, okay, and we have these informations, okay, on my data set here, okay. I will create a directory, models here, to generate the models, okay. Here we generate the models, okay, for example. And when you apply this information, okay, here, okay, we filter, okay, here, the first step is, okay, sorry, I have created here a specific function, okay. I want to classify, okay, the different drivers and for the different races, okay. The idea is, okay, we will create 3 classes, not 2 classes, 3 classes, okay. If you are in the position 1, 2, 3, okay, it is in this class, okay, you are in the class 1, okay. If you are superior to the position 10 at the end of the race, okay, you are in the class 3. Between 4 to 10, okay, you are in the class 2. Okay, now we try to classify my data set. Okay, the data set is you are the different drivers are in the class 1, in the class 2, in the class 3. Okay, we create this function here. Okay, a position index. Okay, the idea is to use the information from in my model constructor reliability, to use the driver confidence, and to use the classification, okay, here. Okay, donc we are using this information, and I will apply the model only for driver without using the constructor, okay, information. Donc we are using the Grand Prix, the positions, okay, and the qualifying, the driver, the age of the driver, the positions, the final positions, okay, the driver confidence and the active driver, okay. We are using this information. We filter the data with active driver, and we apply some all the variables, all the features must be scaled, okay, between 0 and 1, okay, in machine learning, okay. For the method, okay, we are using the scaler, the standard scaler, okay, here, to scale all the variables, okay, all the categorized variable, we transform all the categorized variables, categorical variables, okay, directly. And here we apply these models, okay, directly, the 6 model. Logistic regressions, okay, the decision tree classifier, the random forest classifier, the super vector machine, the Gaussian naive Bayes, and the K-neighbor, okay. We apply the 6 method, okay, here, okay, and we are using the stratified k-folds, okay. It's a method, the k-fold, to create, to search the key, okay, for the classification, okay. We are using the classifications, okay, in my predictive model. I want to predict in which class, okay, this driver should finish in the next race, okay. Donc we are using the stratified k-folds, the cross-validations, okay, and we are executing here, okay. You have the information, okay, on your model. And if we plot these informations here, okay, you can see, okay, it seems the random forest classifier only for driver, it is the best, okay, the best model here for the driver, okay. You can see this information here. If we are executing for constructor, okay, we are filtering the information for constructor with the constructor reliability and the active constructor. Okay, so we can do the same. Okay, we transform the categorical variables. We apply the same methods here. Okay, we use the same process, and you have another accuracy here. Okay, and if you compare the model for the constructor, okay, you can predict the constructor for the next race. Okay, in which category, in which classifications, okay, it could be, in which class, okay. For example, here, the SVC seems better, okay. The random forest has a good accuracy, okay. The Gaussian is really bad, okay. Donc you can check the different that you can compare, okay, for the team here, okay. And we can apply the same method here for the driver and the constructor, okay. I don't have time, okay. Donc, okay. Here you need to build your data set with the next column, okay. Okay, we need to build this information, okay. I will help you, okay. You need to put here, okay. It is the result, okay, for this notebook. I will go directly to this part. Okay, you need to copy this code, okay, in the response, okay, directory. We select directly the information for the driver confidence, the constructor reliability, active driver, active constructor, okay. So you select all this column. We apply the filter for the driver and the constructor, active constructor and active driver, okay. We scale, okay, we use the standard scaler, okay, we transform the different, okay, the different categorical column, okay. We prepare the data set, okay, for predictive value, okay. Here, okay, I'm using the position index to classify, okay, from the position to classify to put the category, no? Okay. You have finished first, okay, first or second or third positions, okay. You are in the class, in the category 1, okay. It's a really simple classifications method, okay. We are using this method, okay, and we can use, for example, for the machine learning, okay, we are using the same methods, okay, with this data set. We are using the stratified k-folds, okay, and you have another accuracy here. If we plot with a box plot, okay, we have the driver and the F1 team, okay. You can see the best model, okay, it's random forest here, random forest classifier, okay. Donc, when you execute these notebooks completely, okay, you have all this information, okay. Here in the other notebook, you need to copy here and before executing the notebook, okay, on this part of these sections, okay. And you can compare the 3 machine learning models, okay, the drivers, the constructor, and the driver plus constructor, okay. So we are executing here these functions, okay, comparing the different linear model, decision tree model, random forest model, CSVC model, Gaussian naive Bayes, and KNN, okay. And here, if you plot this information, okay, you can compare in this, okay, the different accuracy, okay, and probably depending on the method, okay, we could, okay, the only driver, the only team, or the combined data, okay, the best accuracy is for random forest, okay. It is the best solution, okay, to classify this predictive model, okay. Or you can execute all this information. It's yes, 40 this number of seconds, okay, for these executions. And we have executing these informations, okay, and you can generate your predictive model here, okay. using the next notebook, okay, we can save, okay, my training model, okay, from random forest, okay, in this notebook, okay. We can generate the different dictionary, okay, here, using the pickle library, okay. The pickle library on Python, okay, can save the different models, okay, or the different data set with the different dictionary directly on a file, okay, here on this directory, okay. Here, for example, you can generate these files. I will show you, okay, the pickle file, okay, the random forest classifier, okay. It is the models, okay. We store the models, the training models on this binary file, okay, and we can use this binary file for my prediction, okay, to predict for 2021. Okay, look, here we are using this information, okay, to generate the different dictionary. Here, okay, for the driver confidence, the reliability, okay, and for the different for my random forest model, okay. You can save all the models if you want, okay, on this directory. I have saved only the random forest because it is the best model. Okay. Here we are executing this information. Okay, some driver predictive dictionary. Okay, using we are using this notebook. Okay, to save the predictive model. To calculate the probability, okay, after the last race, okay, we need to apply this method after each race, okay, because it's moving, okay. The probability for a pilot is depending on the previous result, okay. Like if you execute in August, or if you execute in July, or if you execute now in December, okay, for example, now Hamilton and Verstappen has the same number of points, okay. In August, it was not the case, okay. Like probably the Red Bull was more reliable in August, okay, if you compare with the reliability today, okay. Donc we are using these functions to calculate the probability after the last race, okay. Donc we are using this information for 2021, okay, the data set for 2021, okay. And we are calculating the number of points, okay, depending on after each race, okay. We are calculating here, okay, the probability for the different drivers, for the different constructors, okay, to win the race, okay. We calculate these probabilities here, okay, and we can generate, okay, the qualifying data set for the predictor, okay. My predictor, okay, you can select, okay, for 2021, okay, these informations, okay, here, and we can generate the qualify filter in CSV, okay, directly here. To generate my machine learning model random forest, okay, it's the same. I save the model, okay. We are using pickle, okay, here, and we are executing in this case, okay, directly the random forest, okay, here. So random forest classifier, okay, and we are executing this information with the best parameter, the fit, okay, we fit with my predictive model, we fit on 2021, okay. We are executing a number of iterations, okay, all these parameters from my random forest, okay. You can change all these parameters, okay, you can tune if you want, okay, directly these informations. Okay, we are executing these informations, and we generate my random forest, okay, the picker here, okay. This information, okay, it is this file, okay, it is my model, okay, my best model, okay, for this classification process. You have the different feature here, okay. You can print the feature importance, okay, for your random forest. You can plot these information, okay. We have lots of plotter, okay, to plot the feature importance, okay. Here, okay, yes, okay. Look, you can see, for example, on the feature importance for the random forest, it is a qualifying position, okay. It is a big, okay, the big parameter, okay, depending on your qualifying positions, okay, you can predict your final category classifications, okay, in which category you are, okay. The constructor, it's not really a big, you don't have big importance with the constructor. For example, the reliability of the constructor, it's really important. It's more important than the confidence, okay. It is a probability, okay, for the driver and for the constructor to finish the race, okay. Donc, in my model, okay, we are using this information. Okay, you can see I don't use, okay, in this model, I don't use the wizard, okay, it's for beginner, okay. No, we can modify this notebooks, okay. You can modify the previous notebook, the 04 and the 05 to use the wizard, okay, because the wizard it's really important, okay. Some driver, okay, could drive very good with a weight wizard, okay, for example Hamilton or Verstappen, and other driver not like, okay, to drive, okay, with a wizard, okay. No, probably the wizard is another parameter I don't use in this model, but we can apply, okay, in the future. We can modify this code and we can apply for the wizard, okay. We can add the wizard, and probably you could see on this feature important, the wizard is really important, okay, because probably this wizard could modify the driver confidence and the constructor reliability, okay. We don't apply here. You plot, okay, the decision tree for the random forest, okay. We are applying here, okay. We are plotting the random forest, okay. The random forest, it's a tree, okay, using the different feature with the different probability on the different feature here, and you have the tree representation here, okay. For example, here, okay, for the first estimator, okay, and you can print the different tree if you want to analyze, okay, if you want to explain the result, okay, at the end. The second decision tree on the random forest, okay, you have these representations, okay, and you can calculate the estimator, okay, for the random forest, and you have all these representations, okay, because we are using an estimator here. If I check the estimator, okay, number of estimator 100, okay. We put on the random forest classifier, okay, we are creating 100 decision tree inside the random forest classifier, okay. So we could print, okay, 100 decision tree, okay, or I print only here the five decision tree, okay, but you can print also decision tree if you want, okay. It is to explain, okay, the result of your predictive model, okay. Yes, is it clear? Any questions on the chat? I will check on the chat. No questions. Okay. Okay, look, we are generating the predictive model. Okay, we have this predictive model here. Okay. On this directory. Okay. We are creating on the web directory an applications. Okay, here you have an applications. Okay, we are creating a Flask application here. Okay, we are using the predictor.py. Okay, here. Okay, it's a web application, really simple applications. Okay, I want to create a web interface directly for 2021 and to execute with a predictor, okay, for example, here. And you can load your driver dictionary, your constructor dictionary, okay, your predictions, okay, after each race, okay. We have this information on the probability of this driver, okay. This prediction is moving after each race, okay. Okay, it's really important to apply after each race this to calculate the probability. Okay, you need to calculate this information after each race. Now, for example, okay, after the last race, okay, probably Hamilton has more probability to finish in the top 3, okay, if you compare with the previous race, okay, or the race in August. I will check if I have some message on the slide. No, okay. Okay, here we have this information. Okay, we load the information. Okay, my clinic data, the qualifying filtering, the last race. Okay, but you need to calculate after each race the last race. Okay, the qualifying last. Okay, race, because it's not the same probability. Okay, if you apply this model on Thursday, on Friday, on Saturday. Okay, because if you use the information from the qualifying data, okay, you have more information on the behavior of the different driver on each race, okay? But you have the information from the qualifying 1, the qualifying 2, and the qualifying 3, okay? And if you use this information, you can perform the predictions, okay, on your data model. But we are using this, okay, we are using my random forest PKL, okay? We are using the my classifications, okay? You finish in the podium, okay? You finish in the point, okay? From 4 to 10, or you don't have point, okay? On this rate, okay? We calculate the classification for each drivers, okay? In my predictor, donc we predict here, okay? I'm using the data model. If you check here, okay, we are using the Grand Prix, we are using the qualifying positions, the constructor, okay, the driver probability, the driver encoder and the constructor encoder, and the driver confidence and the constructor reliability, okay, because it is the information we have used in the 04 machine learning model, okay. Donc, you can predict for each race, okay, using this predictor, okay. Donc we are using this code, the predictor PI, okay, from the APP PI, okay. Here we are creating a Flask API, a Flask applications, okay. We are using the active driver here, okay, and the active constructor, and you can apply, okay, directly this information, okay. If you check on your instance here, okay, I will check if I can connect. Okay, we should have these applications loading directly on this port 8443, okay. So now if you put this application here, we'll check this. I suppose it has been in executions. No, my website, okay. It is not started, probably. By default, it is not started. 8440. No, we don't have application. Okay, but you have a script. Okay, here. Okay, if you check on the console labs, in the last part of the console lab here, in the UI access. Okay, to deploy. Okay, to predict the 5 drivers. Okay, for the next race. Okay. I have explained all this part. Okay, you have this information here. Okay, your predictor. Yes. Okay, you need to start your applications. Okay. Here, okay, this app. Okay, at the end. Okay, yes. In the main. Okay, we start on the public IP on this port. Okay, we execute this Flask applications. Okay, and you have the Slack ready. Okay, you have your index. Okay, on the Flask application. Look, I need to start my applications. Okay, you can execute here if you want directly on the terminal. Okay, you are in the same environment here. Okay, and you have your launch app here. Okay, you can execute. I can take this code here. Yes, copy. Okay, now I can check. Yes, okay, I'm listening on this part. Okay, I can execute here, this information here. Okay, advanced, okay. And now you can select, okay, the circuit, okay. For example, well, okay, and you can predict. And you have the different position here, okay, and the probability, okay. Okay, the predictor thing, okay, Lewis Hamilton, Verstappen, Valerie Bottas, okay, it should be in the category 1, and probably after Lando Norris and Sergio Perez, okay, here. But you can use this predictor, okay, you need to execute this predictor after each race, okay, and after each qualifying step, okay, for the new race, okay. And you can predict better. Probably on Friday, you can predict better if you compare with Thursday, okay, on the previous race, okay. And you can use this information that we can perform, okay, because we're here I'm selecting, okay, I put this filter, but I'm not using this filter, okay. It's for the next, it's for the next implementations, okay. If you want to perform this predictive model, okay, you can add this information and you can use this information on the filter. Okay, now I'm not using the wizard, okay. The code has been prepared, okay, to use the circuit and the wizard and all the information on the drivers, and but I don't use it, okay. Okay, okay, we are starting these applications, okay. So application 1, okay, okay, I'm using the circuit, I'm using the predict, okay. I'm using the wizard, okay, but I don't use the wizard, okay. Here, okay, you can see here, the code is prepared, okay, to use this, but my model, okay, it's a beginner model, and I don't use the wizard, okay, in this model. If you want to perform this predictive model, okay, you need to come to the 04 notebooks here. You need to change on your dataset here, okay. You need to use a wizard. You need to add the wizard, okay, on the different information here, okay. You need to add the column wizard if you think wizard is really important for this predictive model. And you can apply the same, okay, and you need to change these informations, okay, in the 04 and the 05 and in your predictor code here, okay, to use this feature, okay. If you want to add more feature, because I think other feature could be interesting, okay, we can predict using some probability on the does not finished, or you can use this information, okay. We can modify the model. Yes, okay, the next step, okay, we have finished this console labs, okay. So from the lab 1 to the lab 7, okay, we have deployed the applications and we have applied these applications, okay. It is a really simple model, okay, to explain the methodology, okay, to deploy on the cloud. We are using only open source, okay, on this cloud, okay. We are only using here my compute machine, okay, using the Terraform script. We have deployed this information here, okay. We have deployed the Red Bull labs, okay. It is a virtual machine, okay, and in this virtual machine we have prepared a specific environment here, okay. We have prepared a Red Bull environment, okay, with a different library, okay, for executions, okay. We have a Python stack, a Jupyter lab, okay, and well, it's really open source deployment, okay. If you want to use other services, okay, on the cloud of Oracle, okay, we have other services here, okay. We have data science, okay, it is another service, okay. We have AI services, okay, and on this console labs, okay, you can deploy data science, okay, and you have a specific environment with more libraries, more automation, automations to deploy your machine learning model. Okay, look, it is another service. You can deploy this environment. We have here another AI language, AI services, for example, for languages, anomaly detections. Okay, here if you click, okay, you can use this service. Okay, we have pre-trained model. Okay, directly. Okay, it is for language detections, for name entity recognition, text classification, sentiment analysis. You can use all this information if you want. Okay, or you can deploy on your notebook here another sentiment analysis. Okay, with open source. You have different services available. Okay, for this type of analysis. Okay, you can store your information in databases. Okay, directly here. Okay, you can use Oracle databases. Or you can use Analytics Cloud, okay, to use some specific tool to deploy and to execute some drag and drop ADA analysis. Okay, you have different tools, different services. Okay, if you want to have more information, don't need to contact, okay, the DevRel, the Oracle developer relations team, and we can help you, okay, to the different services. We have other answer labs if you want to participate to other answer labs. Okay. Now I will go to finish. Okay. Now, here you have some other hypotheses. Okay, for the model. Okay. Well, we have done this. Okay. I want to predict the possible next winner. Okay. Look, I want to perform my model. Okay. We have used this information on this today. Okay. Qualifying position, constructor, driver, okay, driver confidence, and I can use this information if I want to predict better. Okay, for example, I can use the race wizard, I can use the tire strategy. Okay, because depending on the tire strategy, okay, you have lots of changes, position changes. Okay, for the pilot, like it should be interesting. Okay. Each constructor need to choose 5 type of tires, okay, between 7 type of tires, depending on the choice for the different constructor. Probably the classification is not the same. Okay, probably the engine information could be interesting because they need to use only 4 engine per year. Okay, some other feature could be interested to integrate on my machine learning model, okay, to predict better. Okay, now we have a predictions, okay, with this data set, but probably we could predict better. Okay. In conclusion, we have seen on the cloud of Oracle this console labs. Okay, if you want to put, I will put on the chat now, okay, this information. Okay, if you want to receive the badge, okay, you need to put on this link, okay, you to fill the quiz, okay, on this console labs. Okay, if you fill this information, okay, you will receive this badge, okay, from the different console labs we are doing with Red Bull. Okay, and if you want to have more information, okay, you can connect to developer.oracle.com Red Bull, okay, or if you want to participate to other event for other console labs, okay. We have a series of console labs on using the Formula One dataset, okay. We have another console lab using CellGP too, okay. You can connect to developer.oracle.com/events, okay, and you can put your feedback in this link, okay. That's all. I don't know if we have some questions on the.
Hi, Oliver. Up to this point, I don't see any questions. Anyone has any questions? Just waiting to see if anyone will post anything here in the chat or by the Facebook. Just waiting, and I'll let you know in just one moment.
Okay.
In the meantime, thank you so much, Oliver, for another excellent session. The one you gave 2 days ago and this right here was excellent. I think so. This is a material that everyone should review. And Also, if you have any questions watching the replay, the replay of this hands-on will be available until the 30th of December in the platform for the assistants. Please remember to register to the session. This way, this recording will be available on your personal agenda as an attendee with the replay. And if you have any issues or any questions that regarding this, you can contact myself, Francisco Munoz Alvarez, or Olivier Perard directly through his email or Twitter handle, and we will try to help you the best we can with any issues you have with the hands-on. And saying that, Oracle Programmer Survey or a Programmer Survey with...
I put the information from the presentation.
Oh, fantastic.
Okay, that's the chat.
There, good. I just saw right here. Oh, great. Yep. Earn your budget and everything else. Good. I will add this to the description, in the description of the replay, that the people will know exactly information plus the links for the lab instructions and step-by-step and everything. Fantastic. Now, thank you so much, Oliver. And thank you again for taking the time for doing this session for our Asia Pacific. And for sure, people from all over the globe will enjoy it. And please take care and be safe. And hopefully we can see each other face-to-face in one event around the globe in the near future.
Okay. Thank you, Francisco, for this event.
Thank you. Bye-bye, everyone. Have a wonderful
Bye-bye.
evening, day, or afternoon.
CloudDB, shaping your new normal.